Hi everyone, my name is Alex Vlahopoulos, Sales Specialist at Subspace. In this video, I'll be providing an overview of what Subspace is, our mission, and a walkthrough of one of our TCP/UDP optimization services called PacketAccelerator. So, what is Subspace? Subspace delivers the only true solution that improves real-time application performance. It is a global network built for real-time applications. Quite simply, the internet wasn't designed for real-time traffic, and that's limiting its capabilities globally across all industries. And it's our mission at Subspace to change that. The internet was never built for speed and performance use cases, and it's now real-time applications, video games, live betting, fintech apps, meeting apps, etc. that are most negatively impacted. So we've built an internet made for how the world works now, which in many cases means supporting remote work or the shift to the reliance on the internet for real-time activities. Our network allows us to know more about traffic from a holistic perspective than almost any other provider. This in-depth expertise has allowed Subspace to build the weather map of the internet that accurately tracks conditions in real time. By understanding every step in the route instead of just the immediate endpoints, and by understanding all of the conditions along the way, Subspace can optimize the real-time application journey. Let's take a look at how Subspace works. What Waze does for traffic on our roads, Subspace is doing for real-time internet traffic. Our network consists of a combination of software, hardware, and intelligent routing. We provide low-latency UDP, TCP streams from anywhere in the world to anywhere else in the world. To do this, we partner with ISPs and telcos to deploy our own hardware and software solutions within the data centers. They obviously take care of installing fiber, bringing routing systems and connectivity up. They don't do much with higher level services. That's where Subspace fills the gap. We don't deploy fiber, but optical transceivers and higher are ours. All of our chips are coded and the OS is written by Subspace. So ultimately, we exist to ensure that the internet actually works for real-time apps in a predictable, dependable, stable, and secure manner. On top of this network, we've built a global IP proxy called PacketAccelerator. We can take an IP and port and give you back a proxy IP and port and proxy all your traffic from anywhere in the world to wherever you want it to go. The impact we provide roughly corresponds to 1 millisecond of round-trip latency for every 100 kilometers away someone lives. We finally have that level of determinism in the network. A lot of cloud apps are used to using a load balancer, which provides NAT translation from outside to the inside. PacketAccelerator is similar to that, but accelerates and stabilizes the traffic as well. A load balancer takes thousands of connections and distributes them. At Subspace, we can get traffic from anywhere in the world to your load balancer far faster than having a load balancer by itself. Again, you provide an IP and port, we give you a proxy IP and port, you can request the port you want, then you can give Subspace IP port and give it to your clients. So instead of the load balancer in your A record or DNS record, you put Subspace. It's that simple. Additionally, Subspace fits the bill for why many go to CDNs. They look for how you can protect against denial of service, how do you improve connectivity, etc. If you're just trying to bring a service online, you just get one transit connect and offer your service, but less than a quarter to half of the globe will not be able to use it. CDNs can have cacheable content everywhere, but can't do effectively for non-cacheable or real-time traffic. For example, with video games, traditional CDNs can handle a game patch or download really well, but not the actual game traffic. We're effectively a real-time CDN. In terms of latency, ping times and request response time, we not only lower that in vast majority of cases by as much as 80 to 90%, we keep it stable as the internet changes, fiber cuts, as routers get upgraded, as network changes with normal operations, we handle and remove those complexities from the application. So instead of getting dropped from a match or a call in the event of an internet event, you'll notice a blip and then carry on. And for security, DDoS attacks can overwhelm servers or saturate your network. We remove and scrub clean at the source inside the ISP where the botnet exists without any impact to your users. Let's take a look at an example of a real-time application that could take advantage of Subspace's PacketAccelerator. Organizations who have deployed virtual desktop infrastructure, or VDI, have often faced the challenge of maintaining a reliable network to support that application in order to maintain a good user experience. However, with many users working remotely, maintaining a low latency network for clients connecting from different locations using different internet service providers becomes a constant battle. With Subspace, we simplify these deployments and reduce the burden on internal IT teams by optimizing the traffic between the client's virtual desktop infrastructure. From the client perspective, they connect in the same way that they were connecting prior to the organization using Subspace. For example, if the client was connecting to a VDI domain like citrix.companyabc.com, they still connect to the same domain. The only change behind the scenes is that the IP that domain resolves to is now a Subspace IP and port. Okay, this is really exciting. We're actually launching our console in the next couple weeks. Our console will offer users the ability to easily configure and connect to our network. So let's take a look at what that looks like. In our Subspace console, a user will be able to log in and go to our PacketAccelerator, and they'll be able to create a PacketAccelerator quite simply. So for example, I can name it. I'll call this one North America VDI. Add a destination IP address. Let's do 99.250.10. And then I select my port. So this would really ultimately be the destination IP of my VDI server and the port that it's on. I can choose UDP, TCP, or both and create. As soon as it's created, you'll notice here that Subspace has provided me a Subspace IP and a port pair. I would then in turn change my DNS record to reflect this IP and port. And ultimately, my clients, if connecting to that domain, are now really connecting the same way mechanically, but behind the scenes are connecting through Subspace. That's it. Thank you for joining me today. And if you want more information, please sign up on our waitlist to get access to our private beta with our console. Sign up at www.subspace.com. Thank you.